This brief light is on the photoelectric effect and the work function for quantum nuclear physics. So there are two theories: light is a wave or light is a particle. If light is a wave, then the energy should be in the amplitude, just like energy is contained in the amplitude of any other wave. So for example, a tsunami, which has a huge amplitude, has far more energy than just your regular 1-foot waves that are rolling into the shore. If it's a particle, then something else has to determine the energy. So what I'm going to do is I'm going to run a virtual lab, and I'm doing this virtually for a few reasons, which I'll explain in a minute. This applet has a battery. We're going to ignore that, but we do care about the current. Now, what we see here is a light, which I can change the color of the light. I'm going to set it to red, and I can change the brightness of the light, which I will do in a moment. Now, the light is going to shine onto a metal. In particular, I'm using sodium. Sodium will give up its electrons much easier than other metals. If there is enough energy from light that hits this metal, the electrons will break free. They will skid across and hit this panel here, follow the wire, and complete a circuit. So it'll generate current. Again, the battery, we're not going to worry about the battery. I'm just going to keep it set to 0 so it doesn't do anything. Now again, if light is a wave, the energy is contained in the amplitude, or how bright the light is. If it's a particle, then it's going to be something else. So we start with red light. We'll turn on the red light. 10%, no activity. 20, nothing. 50%, nothing. 60, 70, 80, 90, max brightness. We see that the amplitude of this red light is not doing anything to the metal. So red light doesn't seem to contain enough energy to break free electrons. We'll turn the light off, and we'll switch it over to purple. As I turn on the light, we begin to see electron movement. Now, what this is showing us in this experiment, as we see, we got quite a bit of current here. All these little electrons are making their way across. What we're seeing is it was actually the color of the light that determined how much energy instead of the amplitude. If I bring the color to blue, we still got activity. Into a green, we're still getting activity. Yellow, suddenly there's nothing. So what this means is this is a lot of support for the particle theory, because the energy is not contained in the amplitude like it is for all other waves. So this is again evidence for the particle theory of light. The photoelectric effect is supporting the particle theory of light because the brightness of the light does not determine whether or not you will generate current. It's the color. So how does this all work? What it means is light is traveling like a wave. It experiences wave-like properties when it's in motion. However, when light hits matter, it behaves like a particle. So it has both properties, but not at the same time. When it's moving, it's a wave. When it hits things, it's a particle. Now, let's kind of go back to this experiment here. What we see happening is yellow doesn't do anything, then your greens, blues, and purples do. So, what does this all mean? How does this work? Let's run through an example. we have electrons on this plate that are seeking energy to break free. Your blue and purple light can do it. Your red light doesn't have enough energy. So we'll go back to the blues. Blues have enough energy. The electrons get that energy. They break free. They fly across, complete the circuit. Notice too, as I dial this down into some greens, notice the electrons are moving very, very slow. Yes, they had enough energy to break free, but they really didn't have that much energy. When I get into the purples, you can see they're moving very, very quickly. Let's make an analogy. In this analogy, you are the electron. As the electron, you have a certain amount of energy. In this case, we're going to use money as the energy. You have $5, and you're in prison. Now, fortunately, the guard outside can be bribed, but he wants $50. He's a little weird in the sense that he only wants $50. If you don't have enough money, he'll turn you away. If two friends come up, no good. It only can be one person with at least $50. If your friend has more than $50, he'll only take $50, and then you get to keep the rest. So you are like the electron on the plate. You are trapped by the atom. You want to break free. You currently do not have enough energy to break free. The work function is the amount of energy required for the electron to break free. In our analogy, that's the guard. He wants $50. Now, your friends over here are particles of light. Only one friend is allowed to approach the guard at a time. So we'll use red light, which in our analogy did not have enough energy. The electrons could not break free. So your friend, red light, comes along to the guard and says, "Hey, I got $40. The guard says, "No, thank you," turns your friend away. Nothing happens to you. You're still stuck in prison. Just like the red light hits the metal plate, there's not enough energy to break free. Nothing happens to the electrons. They're still trapped. Why doesn't the brightness do anything? We can see low brightness, high brightness doesn't do anything. Just like we saw if we went to purple, even low intensity purple light still releases electrons. High intensity can release a little bit more. So let's take your friend, red light, again, comes to the guard, says, "I got $40. Guard says, "Not enough." Friend gets turned away. Red light, not enough energy, nothing happens. Dim red light, nothing. Moderate red light, nothing. Bright red light, nothing. That's like saying, dim red light, one friend comes, $40, no thank you. Okay, you got two friends now. First friend comes, no thank you. Guard says, "Nope." Your second friend comes along, "I got $40 too." "Nope, not enough." The problem is only one friend or only one particle of light can interact with the guard or the work function at a time. So even if you had a whole bunch of friends of red light, 40, 40, 40, 40, 40, only one can interact with the guard at this one time. Therefore, unfortunately, since only one can interact and the guard wants 50, there's not enough energy. Too bad. Okay. Now let's say blue light, your more wealthier friend, comes along and says, "I got $70. Guard goes, "I want 50. Perfect. The guard takes 70. Your friend vanishes. It's not to be violent, it's just how light works. Of that 70, the guard took 50. Except the guard didn't even need 50. The guard only needed 45 because you had 5 yourself. So you gave 5 to the guard of the $70 that your friend had. The guard took the remaining 45 he needed to be happy. That left you with 25. As a result, you get $25 on top of your freedom. You get to go away. Let's reset the scenario. We'll bring your blue friend back to life. Green friend comes along. Just like we see here, blue was successful, but so was green. We did notice, though, the green electrons did not have a lot of energy compared to your blue and violets. So the green friend comes along. I have $55. Guard looks at you. You got $5. Guard says, alright, you got 5. Your friend's got 55. I only want 50. Because of the way light works, your friend disappears. Takes 45 from your friend. Takes 5 from you. When it's all said and done, you're left over with $10 all to yourself. Reset the scenario. Once again, red light friend comes over. I got $40. Guard looks at you. That's 5. 40 and 5 is 45. He wants 50. No good. Blue light friend comes along. $70. Looks at you. 5. Looks at your friend. 70. That's 75 total. Awesome. I only want 50. He takes 50. Friend disappears. You break free. Except instead of $5, you now have $25. You're happy. Guard's happy. You're free. Coming back to here. Red light. Not enough energy. No thank you. Green light. There's enough energy, but not a whole lot is left over. Therefore, not much happens. Blue light. Not only do you have enough money to break free, or enough energy for the electrons to break free, there's even extra energy, so the electrons got a lot of kinetic energy or high speeds. Thank you for watching.